Hello and welcome to episode 6 of Learn Java for Complete Beginners. In this episode I'll make inheritance easy to understand. Let's begin. Firstly, we'll start off with what's called a parent or a superclass. This class contains information that would be relevant to other classes. In our example here we have our main class, which is the one we're currently in. We have these three other classes I've created earlier. In here we have vehicle. Let's go into vehicle and take a look at this class. This class accurately describes what we want from a vehicle. It has an integer number of wheels, fuel consumption rate, fuel amount, and the vehicle name. It also has a constructor here, which takes in a number of wheels and sets the wheels locally. And we have this method here called drive. This method simply takes the consumption rate and the number of wheels, sets the consumption rate based on the number of wheels times 3, and kind of like ticks down all the fuel amount based on that consumption rate. We don't quite need to worry about this thread.sleep here or this try catch statement. Just know that this drive method depletes the fuel. At the end of this method we print out how much fuel we have left after one time through, and while fuel amount is not 0 we continue doing that. Once we hit 0 we set the amount to 0 here, so that's simply so it can't go into negative numbers, and then we print out that the vehicle has run out of fuel. This is going to be our base or parent class in this example. So next we're going to look at something called a child class or a subclass. In here we have two child classes of the class vehicle, one being car and the other being motorbike. If we go ahead and look in our car class, it's a relatively simple class. The first thing we noticed is this thing called extends here. This is a new keyword we haven't seen before. Extends means it inherits from class vehicle. You can only inherit from one class at a time. So if I try and inherit from main, for example, it's going to give me an issue here saying cannot extend multiple classes. The next thing we notice here is the car's constructor, a relatively simple constructor, but it does contain a keyword we haven't seen before. It contains the super keyword. As you can imagine, super relates to the superclass. What this method here does is it's just the word super with an empty brackets, or in this case it has a number of 4 in. This is calling the inherited classes constructor method. So if we look again back into vehicle, it takes in an integer number of wheels. This inherits that, so we can call that constructor here and pass in the number of wheels. For car we're passing in 4, so that's how that works. Here we have super.fuel amount. Again we're referencing the superclass. It has the fuel amount. This is just being explicit in this instance. You don't need this, you can do that because there is no local fuel amount in here. If there was, and there was a variable with the same name, you would have to be explicit, like super, for example that. But this is just being explicit to say we are setting the fuel amount of the superclass to 200. And the same is going on here with the vehicle name. If, however, the vehicle variables are private, I know we haven't touched much on scope, we will in the future, but if these variables were private and not default package protected as they are right now, for example if fuel amount was private like so, this wouldn't work, simply because it's a private variable. So to tackle that, what we'd do is we would take in the variable we wanted here, so if we call that int fuel amount, and then in here set that, so this dot fuel amount equals fuel amount, like so. You could then in here get rid of that and say 200 in here like so, and that's how you would set that if it was a private variable. We're not going to do that, however we're going to keep the old way of doing it, which was like so, simply because there's no need for that to be private. We can also override a method in here. To do that we just create a method with the same name like so, and then we can go ahead and use that. So what will happen is when this class is instantiated as an object, it will use the subclasses method over using the vehicles method. Now what if you want everything to be the same but then something very different? So you'd again call super like so, dot drive like so, and then you would do what else you wanted to do. So dot print line, let's see this and say car subclass method called. So what this will do is we'll override the vehicle's drive method, and it will, because in our method here we're only going to do this method, then what happens is we're saying call the superclass's drive method first, so do all this first, then once that's done we can print out this. So that should do both. If you just wanted to override it and you didn't want the superclasses method in there, you'd just do it like this, and it wouldn't do that, it would do this instead. So that's how that works. If we go ahead and take a look in the motorbike class, it's the same as the car, apart from the values are different. Number of wheels is less, the fuel amount is less, and the name is obviously different. What we're expecting then, based on this drive method here, is because the number of wheels is less, the fuel consumption rate will be less, which means it depletes slower, but at the same time it also has less fuel, so it might take more ticks to get down, or less ticks to get down, depending on those two variables. If we take a look in the main class here, I will open this up. As you can see, I've instantiated two of the classes here. The first one is just instantiating the car. As you can see here, the motorbike is instantiated as a vehicle. Motorbike equals new motorbike. That works completely fine. And then there's no difference between these two really, other than one's a car and one's a motorbike. You can instantiate either way. And then car.drive and motorbike.drive. We're going to run this and see what happens. So if I go ahead and click run here, expect it to build. Car has 188, 176, and so on and so forth, and it will continue to do this until it runs out. Let's see. It appears to be going down by 12, and if we do the maths, four wheels and times 3 is 12, so that's legit. Again, this is the motorbike, has 2 wheels times 3, that's 6, and then there we go. What's really interesting is the car subclass method called here. That just shows that our overrided method worked. Fantastic. One final thing on overrided methods, you can be explicit and say override like so. That way, as a developer, you can see it's overridden, and for example, if we eventually delete this method for whatever reason, this will throw an error saying that vehicle the vehicle class no longer has this method, and as a developer we can see that quite clearly. If you didn't have that there, and of course there's no super in there either, then you would be unaware and you would just be calling this drive method, even though that might not be the desired outcome. So you can be explicit and say override like so. The next thing I want to get onto is something called an abstract class. When I was first learning Java, this is a concept that really quite scared me. Just the word abstract really kind of threw me off. It's nothing too complicated though, so please don't be too worried by the terminology. All an abstract class is another template for classes. Okay, so a class is a template for an object. An abstract class is a template for a class, and I think that's the best way to describe it. So if we just do some code here like that, so if we call this an abstract class, that means now that this class can never be instantiated. You are not allowed to instantiate this class as a vehicle. This class contains information that is relevant to multiple different classes, and it can be used as like a template so you don't have to repeat yourself with code. However, this class itself can never be instantiated. It can define methods, it can define variables, it can define the implementation of some methods. It doesn't necessarily have to, we'll get onto that in just a second, but it itself cannot be instantiated, as I've just said. The main use of this is to help rewriting the same code repeatedly over and over again. And another good use of this is abstract methods. So we're going to get into an abstract method here. We're going to call it public abstract void, int, let's call it int, get num of doors. I've got a little bit of lag here. Get num of doors, like so. If we say that, sorry, it's not defined like that. I'm telling you a lie. It's defined like that. What this is basically saying is, because this method is abstract, we don't need to define it here. Any single kind of class that implements this must implement get number of doors. You cannot extend this class without implementing this get number of doors. We're not going to implement it here, but as a contract between the subclass and the superclass, this abstract class states you must implement this get number of doors. Why is that useful, you might ask? Well, if we think about at runtime, when people are passing information in and out, and we kind of want this kind of behavior where we don't actually know what we're accepting. We know it's going to be a vehicle of some type. We're unsure of that vehicle type. How can we be certain then that all those are going to contain a particular method? Well, here's a way of doing that. And all those methods could very well be quite different. So get number of doors, although this won't be different in this case, you could do some complicated logic for a car that's completely different to the complicated logic of the motorbike, and the outputs be what you want them to be and the information you requested. However, the way to get there is much different between them. The abstract class allows you to define that method and say at runtime this method will be there for these particular classes if they extend vehicle. So that's really the use of this. So let's go ahead and implement this method into the car and motorbike class. So here we can say public int, doesn't need to be public, I'm just making it public, public int get num of doors, like so, and we're going to return, is this car? This is car, so we're going to return 4. Like so, just keeping it nice and simple. Same again for the motorbike. Again, you will get a complaint in your class like this usually if you're using a good IDE, and it will tell you you need to implement the methods as seen here. So get number of doors, we're going to do that anyway manually right here, like so, and you can see that error goes away. That's because we've implemented the abstract class. So now let's showcase the abstract method a little bit. If we go back to main here, we have these two drive methods. This is kind of irrelevant to what we're trying to achieve right now, so I'm just going to go ahead and comment those out like so. And what I am going to do is I'm going to have a method. We're going to call it public void public static void print print num of doors. It's going to take in a vehicle v, and it's going to do v dot, so system dot out. God, can I do this? System dot out dot print line, and then we're going to say v dot get num of doors, like so. Now we don't actually care what's passed in here as long as it's a vehicle, and we can ascertain that that will definitely have this method, which is why it's really useful. So what we can do here is we can say print num of doors, and we can say car print num of doors motorbike, like so. And as you can see, this is this could be anything as long as it extends vehicle. We actually don't have to know what it is at runtime. This could be, this doesn't even have to be instantiated prior to this. Like, you can pass it as long as it's a vehicle when it reaches this point. We don't need to know anything else about it, which is really great. So if we print that, we're expecting 4 and then 2, 4 and then 4. Why is that? Yeah, so sorry, I pasted 4 in there, so that's 2. Let's try that again. 4 and 2, there we go. So yeah, we can see how that worked. That's all I'm going to cover in this episode. A similar concept to this is an interface, which will be covered in a later episode where similar behavior can be achieved. So don't forget to subscribe to see that, and I'll see you next time.